LaFonda, I don't get this. I hate science.
What? What?
What?
What?
Science is so cool and interesting.
And it's fun too.
Today we're going to be talking about the formation of stars.
Star, a star, like a star, a star, a star.
Well, it seems like there aren't any stars in the sky right now. But did you know that because of the brightness of the sun, we can't see the stars? So, they don't go anywhere, but our ability to see them changes.
Alright, let's go back inside and start our lesson.
So how are stars formed anyways?
All stars are formed inside a collapsing nebula. A nebula is a cloud of dust and gases.
Material that falls to where the core of the nebula has extra energy and causes the material in the center to spin.
As the pressure and temperature build up, the tightly packed atoms heat up.
And this is when the core starts to glow and it forms a protostar. A protostar is a star in its first stage of
Did
formation.
you know that not all stars are the same? They are divided into 3 main categories depending on their mass.
There are low, medium, and high mass stars.
Let's start learning about low mass stars. Low mass stars use nuclear fuels more slowly than most massive stars.
They can last for 100 billion years, which is the longest lifespan compared to the other stars.
They also have less gravity and pressure.
Low mass stars' nuclear reactions happen at a slow rate compared to the other stars.
They shine weakly as small red stars, also called red dwarfs. Did you know that most stars in our universe are red dwarfs?
When red dwarfs cool, they turn into white dwarfs.
Now, let's talk about medium mass stars. Medium mass stars burn their fuel quicker than low mass stars.
They use up their hydrogen in about 10 billion years.
Did you know that the sun is an example of a medium mass star?
When a medium mass star's hydrogen fuel runs out, the star collapses.
The temperature and pressure of the star then start to rise.
And this is when helium fusion begins. So what is helium fusion?
Helium fusion is when hydrogen undergoes a nuclear reaction and transforms into helium.
The core heats up and the star turns into a red giant.
Once the helium burns out, the star collapses and dies.
Now it's time to learn about the last type of stars, high mass stars.
High mass stars are 10 times the mass of the sun.
When gravity pulls matter into the center of the star and squeezes the core, nuclear reactions speed up.
High mass stars are hotter, brighter, and bluer than other stars.
They use up their hydrogen fuel in about 7 billion years and then collapse.
Heating and compression cause helium fusion. These high temperatures cause the star to expand into a supergiant.
Did you know that Polaris, the North Star, is also a supergiant? It is more massive and about 1,000 times brighter than the sun.
Heating and compression cause the helium fuel to run out and the core collapses again.
The star undergoes several cycles of collapsing and expansion.
A supernova is an exploding star.
It releases enough energy to cause the iron and other elements to fuse into various combinations.
The force of the explosion sends these heavy elements far out into space. Some of the debris forms into new nebulae.
Their main core either turns into a neutron star or a black hole.
A neutron star is between 10 and 40 times the mass of the sun.
A supernova explosion causes the atoms to collapse and compress, which forms neutrons.
A star's core becomes little more than a ball of neutrons called a neutron star.
Neutron stars are made of the densest material known.
The other outcome of a supernova is a black hole. A black hole is more than 40 times the mass of the sun.
An explosion of a supernova causes the star's core to collapse. This occurs because of the gravitational force and the formation of neutrons that don't have the ability to prevent it.
The effect of gravity causes light, time, space, and other matter to fall into a single point.
Did you know that black holes grow the more mass they pull in?
This means that the black holes in our solar system are constantly growing.
Well, we hope you enjoyed our lesson and learned a thing or two.
And now to sum up our lesson, we have a little something for you. Now this is the story of formation of stars, high up in the sky and bigger than cars.
Nebula is where things are formed.
A giant cloud where stars are born.
Temperature and pressure start to rise.
Down in the core, way down inside.
Listen up now.
It's time for a show.
A polar star is born.
When the core starts to glow.
There are 3 types of stars if you know what I mean.
Low, medium, and high mass that are farther than they seem.
Low mass stars are for billions of years.
That takes longer than moving around, so we don't have to fear.
Medium mass stars, an example is the sun.
The speed is so great that we all have to run.
High mass stars are big and strong.
They come to violent ends and don't last that long.
They become neutron stars or a big black hole.
And that's much bigger than my grandmother's nose.
Neutron stars are bigger than the sun by 10 to 40 times.
Oh, I ran out of words. It's hard to name.
Black holes grow with the more mass they get.
And we're not sure where all the matter is yet.
Sorry to say, but this rap will soon be done.
It's not that bad. Learning can be fun.
We finally finished our lesson. We hope you enjoyed our show.
Goodbye for now. It's time for us to go.
And this, okay, hold on.
Explosion.
Shayna, look here. What are you doing putting your lip gloss?
Like a star, a star, a star, a star, like a star.